We're basically going to continue from chapter 11. We started chapter 11 the other time, and we're gonna continue from there today. I think everybody is hearing me clearly, right? Okay, thank you so much. And those of you online, can you confirm if you're hearing me clearly?
Yes, I can.
Okay, thank you so much, and thank you for confirming that. So today I'm gonna walk you through what we call the analysis of categorical variable with logistic regression. But you know what? I'm basically gonna have a recap on this. I told you the other time that we use logistic regression in a situation where the response variable is categorical. Okay, when the response variable is categorical, we use logistic regression. And I also want to tell you this. You know, uh, we could have a predator that is quantitative. We could have a predator that is categorical. We could also have a combination of the two. In fact, logistic regression can still be used. I'm going to say this again. When the response variable is categorical, okay, we could have uh, combinations of categorical predators and quantitative predators. Okay, so we can also use logistic regression. Now, you remember what I walked you through on Monday? Sorry, on Wednesday. I walk you through what we call the analysis of categorical variable situation, where we have categorical response and categorical predator. Of course, you notice we use chi-squared. Okay, we use chi-squared. I remember when I started by investigating whether the variables are independent or not. I started in a mathematical way. From mathematical way, then I also walk you through how to actually investigate whether the relationship that exists is significant using the chi-square. Of course, you remember I told you the chi-square actually measures discrepancy between the observed and the expected. But you know what? You know what I want to do today? I also want to demonstrate to you when we have a categorical table, when we have a categorical variable, when the response is categorical and the predictor is categorical, we can also use logistic regression. I'm going to say this again. When the response, so which means in the analysis of categorical variable, logistic regression can also be used. If you can recall on what we did on Wednesday, the method that we used on the analysis of categorical variable was the method of chi-square. But you know what? The focus today is basically we want to analyze two-way tables with logistic regression. I'm going to show you. The two-way table, we analyzed that using the chi-square on Wednesday, right? Today, I'm also going to show you how logistic regression can also be used to analyze categorical variables. Then we're going to see the difference between using logistic regression and using chi-square. Okay? Now, I'm going to start with a model specification for logistic regression. I wanted to take a look at what I have right now. This is a specification of a simple binary logistic. Why do I call it simple binary logistic? Because I have a categorical response and I have one predator. The predator here is X. I think you know that, right? This is if you look at this and what we've been writing before, you're going to see that I've been writing pi divided by 1 minus pi equal beta naught plus beta 1s. So what I'm not trying to say, do you know the expected value of y given s is the same thing as pi? I wanted to take a look at that. The expected value of y given s, because what you have here is just the expected value of y given s. So pi can actually, expected value of y given s can actually replace pi. Take a look at what I have right now. Okay, and when I say 1 minus pi, so 1 minus expected value of y given s is the same thing as 1 minus pi. And of course, if you take a look at that, I said log odds. Okay, don't forget the odds that I'm talking about is pi over 1 minus pi. And you know what? I can basically, instead of using odd, I can use another a parameter space to represent that. And don't also forget, I can rewrite this as logit of pi is the same. We have several ways we can actually specify that. Okay. Now, you know what I want to do now? Suppose we have two variable, one categorical, it has two levels, and one predator also have two levels. So which means if we have 2 by 2, okay, 2 levels of a predator and 2 levels of a categorical variable, we're basically going to have 2 by 2. So when you have 2 by 2, we actually want to use a logistic regression on that. Now, what are we trying to say? I wanted to focus the board now. You're basically going to say something, applying logistic regression model to 2 by 2. What do I mean by 2 by 2? You know, the 2 by 2 is trying to say we got 2 levels of response, we got 2 levels of predator. That's what we mean by 2 by 2. Okay, maybe you are trying to, we are cross tabulating, you know, the levels of the response against the levels of the predator. Now, you know what happened? It means your predator has 2 levels. Then we're going to call it this. When s equal to 0, when s equal to 1. Because you know why? Why do we say s equal to 0? Why do we say s equal to 1? That's a labeling because the levels of the predator is 2. Now, when s equal to 0, what happened? Plug in 0 into the model. What do you have? In the model, like you see right now, plug s equal to 0. What are you going to have? It's going to give you this, isn't it? Look at that. It's going to give you beta naught when s equal to 0. Don't forget, your predator is a dummy now. It's categorical. Well, when s equal to 1, what is going to happen? Plug in 1 here. Plug in 1. Where you see s, what are you going to have? It's going to be beta naught plus beta 1. Take a look at that. Okay. Now, do you know that if I want to estimate the parameters, how will I get beta naught? Now, take a look at the board. How will I get beta naught? The moment I know the pi's and I take the log of the odd ratio, then I'm going to get the beta naught mathematically. How will I get the beta 1? You know what I'm going to do to get the beta 1? We're going to subtract. What are we subtracting? See, if I have a beta naught plus beta 1, then this, if I do this minus this, what do you think I'm going to have? The beta naught, okay, if I, give me 1 second, I'm going to write something really quick. Now, what I'm trying to say is this. If I have beta naught plus beta 1, and I have beta naught, and I want to get beta 1, what am I going to do? It's going to be beta naught plus beta 1 minus beta naught, isn't it? Okay, this cancel that. What do I have? Beta 1. Okay, so that is what I'm trying to do here. That's what I'm trying to do here. So the beta 1 now is basically going to be, okay, you know, when I subtract this from this, is the same thing as saying this minus this. This minus this will give you beta 1, right? Then you're going to do this minus that too, right? Look at that. It's going to be this guy minus this guy. And that's all you have here. Look at that. Well, that's our beta 1. Now, if you have, the beta 1 is going to be the log of pi 1 divided by 1 minus pi 1 minus the log of pi now divided by 1 minus pi now. You remember the law of logarithm. You know the law of logarithm, right? When you have log A minus log B, mathematically, what are you going to write? It's going to be log A divided by B, right? So that is what I'm trying to do here. The whole of, if I say the log of this guy minus the log of this guy, if I want to rewrite that, it's going to be, I'm just going to write a single log. Then it's going to be this guy here divided by this guy. That is what I have here. So automatically, if I want to obtain my beta 1, this is what I'm going to use to obtain my beta 1. So what am I trying to show now? And what does the beta 1? The beta 1 is a log Hord ratio, and the exponential raised to the power of beta 1 is the Hord ratio. I've walked you through that before. Now, this is just to show you the mathematical way of deriving the beta naught and the beta 1 when you are working with a categorical variable. Now, I want to walk you through this example now. Okay. When you take a look at the example that I'm trying to show now, this is a 2 by 2. Okay. The 2 by 2, we have the categorical response and the categorical predator. Here we want to test the effect of categorical predator on the categorical response. What is the categorical predator here? Okay. When one or two parents, if you take a look at this side here, okay, that's a categorical predator. It has two levels. One of the level is whether one or the two parents smoke, and the other level is neither of them smoke. Now, what is the predator? The predator is two levels, whether student smokes or student does not smoke. What do we actually want to achieve here? We basically want to see, is there a relationship between parents that smoke, okay, and their child, which is the students that smoke. Okay, that's all we want to see here. Okay, so take a look at that. 5,375, okay, participants were actually investigated, and of course, 816. Okay, if you look at the total number of students that smoke, it's 1,004. The student that does not smoke, 4,371. The total number of 1 to 2 parents that smoke is 4,019. Neither parent, the totality of that is 1,356. And when you look at the 816 right here, 816 is a student who smoke, and given that 1 or 2 parents smoke as well. Now take a look at this. This is an example of a 2 by 2. Okay, and when you take a look at this, if you want to use the approach that we use on Wednesday, you're basically going to use a chi-square, right? Where you need to first investigate whether the conditional probability is the same as the marginal. You started investigation from mathematical perspective, and after that, then you go and calculate the expected frequency, and you obtain the chi-squared, and you obtain the p-value associated with the chi-squared, and you're going to take a decision whether there's a relationship between the categorical predator and the categorical response. In this case, when you're doing that, you're actually using a chi-square. Okay, but you know what? The chi-square will only tell you whether association exists or not. But the chi-square cannot, investigate the significance of the predator. I'm going to say this again. The chi-square, what we use on Wednesday for the categorical variable, okay, the chi-square will only tell us whether the relationship or the association is significant. But you know what? The chi-square cannot tell us whether the categorical predator use is significant. There's a difference between having a significant relationship and the predator being significant. Those are two different ball games. And when you fit a logistic regression, you will be able to measure that, right? You will be able to see whether the categorical predator is significant. And that is the idea behind, fitting logistic regression to categorical variable, to situation where the response variable is categorical and when the predator variable is also categorical. Now, I want you to take a look at the R code now. This is the R code if I want to do that. If you take a look at what I'm displaying now, you need to define your explanatory variable. The explanatory variable is a predator, right? It's a predator variable, and it has two levels. Okay. The first level is I'm going to code if one or more parents smoke, I'm going to code that as 1. No parents smoke, I'm going to code that as 0. So that means the levels of the categorical predator here is 0 and 1. Okay, take a look at that. Now, the next thing I'm trying to do here now, okay, then I'm going to tell out, okay, I want to treat that as a factor. And that's why you see parents smoke equal as dot factor 1 and 0. You know what? You know where the 1 and 0 come from, right? I coded 1. If one or more parents smoke, it's going to be coded 1. If neither parents smoke, that will be coded 0. You know what I want to do now? I basically want to look at the effect of the parents' smoke on the students' smoke. And we can only achieve that with the logistic regression model. Okay. Now, you can see that now, right? Now, the next thing I actually want to do is to go into the response. Now, I wanted to see the way I'm going to code the response. You're going to write response less than C by. Now, yes, if you go back to the table, you have yes, and you have no, right? Now, this row is yes. Why do I say yes? Oh, yes, parents smoke. When parents smoke is where if one or two parents smoke, that's a yes, right? 816 3203, that's yes. Take a look at that. So now you're basically going to write, if you see, I wrote 816188. If you come back here, 816188. Look at that, 816, you're going to go columnly. Okay, look at the way I go. 816188. Then 32031168. That is what I have here. Look at that. You see? Do you see what I have here now? 816-188-3203-1168. Let me go back again and see. This is where you're going to go. I wanted to don't use row, use column. Okay, use the response. Response, yes. Now, which column correspond to response? Yes. It is 816 and 188. Look at that. Response yes means students smoke. Okay? If you want to code it, your yes is talking about your response. Not, when you go by row, that's a predator. Row for predator, column for response, but we are interested in the response, right? Now, and that was why here, 816188, that was why you see here, 816188. Look at that. This is column 816188. Then this is the other column where student don't smoke. 32031168. You're gonna see now, student don't smoke. Where student don't smoke, do you see that? 32031168. So that is what you're gonna put in your response. Is there anyone who doesn't understand how the response is coded? Do you have anyone who doesn't understand how the response is coded? Your response is column, and it has, that is the student, whether students smoke or not. When students smoke, okay, that is yes. When students don't smoke, that is no. Now, the next thing is just to write the model. Okay, this is the model now. Smoke.logistic, okay, less than minus GLM, response on parent smoke. The parent smoke is the categorical predator, right? When you have defined that here, you've already defined the parent smoke here, right? And that you are now regressing the response on this. And don't forget, this is your response, right? What are you doing now? You are using logistic regression for categorical data. That's what you're doing now. Okay, now let's see the result. We did a summary. Now we have the result now. Take a look at this. When we use chi-square the other time, you are not going to have a result like this. The only thing chi-square is going to tell you, the chi-square is just going to tell you whether there's a relationship or not, whether the relationship is significant or not. But the chi-square will not tell you how significant is the predator. Okay, how significant is predator? Then we're basically going to use logistic regression. Now take a look at the results. Well, what do you notice in the parent smoke? Take a look at the p-value for the parent smoke. What do you notice? The p-value for the parent smoke is significant. Look at that. The p-value is less than 0.05 level of significance. So which means the predator here actually is significant to getting yes or no in the response. That's what it means. Take a look at it. Now, the next thing now, we're going to write our fitted model. Well, so the fitted model, don't forget, the fitted model is the log of pi divided by 1 minus pi equal to beta naught plus beta 1s. All what you just need to do is to go back into the estimate. Look at the estimate. Can you see the estimate? Minus 1.282661 and 0.45918. That is the estimate. Don't forget the first one is basically beta naught, right? And the second one is beta 1. All what I'm just going to do is just to plug that in. Take a look at that. Now I have the model. This is a logistic, this is fitted logistic regression model. Where do we derive this model? We derive this model from a categorical variable. Look at that. From the table, from the 2x2 table. Look at that. Okay. Now we have the beta now, we have the beta 1 now. And do you know that series of questions can now be asked on this? This is getting it in a logic form. You know that, right? I can also ask you to get it in a probability form. Okay, if you want to get that in probability form, don't forget that you basically, in probability form, I'm going to write that now. So because in exam, in the final, okay, I can ask you to write in probability form or in a logic form. This is a logic form. In probability form, and basically it's going to be exponential, okay, raised to power 1.82 a negative 1.82661 plus 0.45918 star parent smoke divided by 1 plus exponential minus 1.82661 plus 0.45918 star parent smoke. Okay, now what you see now, so this is in probability form. Okay, this is in probability form. Okay, do you know that if I ask you to find if a parent smoke, what are you going to do? What is the probability that the student will smoke? If I ask you that, if I say, okay, determine the probability that the student smoke when parents smoke, what are you going to do? You're going to plug in 1 where you see the parents smoke. When you plug in 1, then you're going to determine the probability. Okay, the probability of what? The probability that students smoke if the parents smoke. Then I can also ask you this: if the parent do not smoke, what is the probability that his student will smoke? You're going to plug in 0 here. When the parent don't smoke, S equal to 0, don't forget the predator we have here is categorical. It can only take 0 or 1. Okay, it can only take 0 or 1. Okay, if they ask you to find the probability, so this is used to find the probability. Okay, now the interpretation, of course, I've written the interpretation. Of course, I told you x1 equal to 1 when parents smoke, and x1 equal to 0 when parents don't smoke. Okay, so take a look at that. And you know what? The group for the parents smoking equal to 0, that is the baseline. Okay, and what do we mean by the baseline? We are modeling the probability. Now, take a look at this guy. I'm going to show you this now. Now take a look at this. In the model, you have a parent smoke 1, right? Okay, you have a parent smoke 1. Okay, the parent smoke 1 is coded 1. Then the parent smoke 0 is coded 0. And that is basically, now what is the meaning if you were to interpret 0.45918? How can we interpret the 0.45918? Don't forget I told you when you have a logistic regression, the estimates are called log hard estimates. I think you remember that, right? Log hard estimate. Okay. Now, do you know we can actually interpret that guy? Let me see whether I provided. Now, this is the interpretation here. The beta nodes and the beta 1, they have interpretation in the platform of, in the framework of logistic regression model. Now, I said the estimated beta node equal to that, with the standard error of that is significant. Of course, we can see looking at the p-value that is significant. You can see here, right? That looking at the p-value is significant. Okay, and then I said it says that, what does it say? Like, how do you interpret the intercept? Let's start with the intercept before you go to the slope. You remember we did the same in a linear regression, where I'm going to ask you to start interpreting the intercept. Now, in the logistic regression, how do you interpret the intercept? It's trying to say the log hard of a child smoking versus not smoking if neither parent is smoking is that. Take a look at that. The log odd. So that value now is talking about the log odd of a child smoking versus not smoking. Don't forget, in the logistic regression model, you have a log odd, right? The log odd, the first, the one at the top is student smoking. The one at the bottom is a student don't smoke. So the log odd means the log of student smoking divided by student not smoking. So the log odd of that was that if neither parent is smoking, if neither parent is smoking, we're talking about intercept. What is intercept? When the predictor equal to 0. And when predictor equal to 0 here, what do we say? That is when neither of the parents smoke. Does that make sense? And that is significant. If you take a look at the p-value, the p-value associated with the intercept here is also significant. Look at that. Okay, it's also significant for the intercept. Okay. Now, the next thing now is how do we interpret the slope? Okay. And, interpreting the slope now is that the log odd ratio of a child smoking versus, okay, not smoking, if at least one parent is smoking, if at least one parent is smoking versus neither parent is smoking, is 0.459. Look at that. That is what we mean. And it is statistically significant, of course, when you look at the p-value. Now, if you now want to talk about the odd ratio now, what are you going to do? You're going to do the exponentiation of that. The exponentiation of the beta 1 is 0.459. We give you 1.58. What does it mean? This is the odd ratio. 1.58 in odd ratio. What does it mean? I'm going to tell you now. See, if I have the odd ratio, pi over 1 minus pi, and it is 1.58. It's like 1.58 to 1. What does it mean? And don't forget here, this represents the probability of student smoke, okay, of student smoke, okay, divided by the probability of student does not smoke. Student does not smoke. What does it mean? Now, when you take a look at what I have, okay, if at least one of the parents smoke, okay, the odd, okay, the odd of the student of the odd of their child smoke is 1.58 higher. Look at that, 1.58 times of, look at that, 1.58 times. When you say 1.58 times of those one that doesn't smoke, that is, it means the odd is very higher for for children whose either at least if one of the parents smoke, they're basically gonna smoke. That is very higher. Look at that here. That's what we mean. And that was why we said, um, you know, um, in the so you can see the difference between the log of odd and the odd ratio now. The odd ratio, if you want to find, you want to get the odd ratio from the log odd, you're gonna take the exponentiation, and that will be 1.58. Okay, if you get one, if you do odd ratio and you get one, you know what it means? That is 50-50, right? The probability is 50-50. That is too dicey, right? But this time around, this is not dicey. This is 1.58 times. Okay. Now, when you have a logistic regression, we do inference. We can do inference about can we get a confidence interval of the log odd estimate? Can we also get the confidence interval of the odd ratio? Now, of course, if you look at the very first thing that I'm trying to do here is to first obtain, the first one here, the value, using the z-square statistic. Okay, we can actually obtain the values of that, which the square of the parameter of the log odd estimate that we got. Okay, that is where you want to test whether the beta is equal to 0 or not. Okay, but you don't need that. If you want to construct a confidence interval for the beta, there's a difference between constructing a confidence interval for the log odd estimate and constructing a confidence interval for the odd ratio. Now, for the log odd estimate, what are you going to do? Okay, you're basically using the beta j plus or minus, okay, z into 1 minus alpha over 2 times the standard error. Now, 0.4592, where does it come from? 0.4592 is the slope. Look at that. It's actually coming from here. Okay, it's 0.45. Then you want to find the confidence interval for that. It's going to be plus or minus. At 95%, you're going to use 1.96. Okay, that's why you see the 1.96 here. Okay, then where is this guy coming from? That is the standard error. Where is the standard error coming from? You're going to see it as part of the output. I'm going to show you now. They will say the standard error now. The standard error of this guy is this guy here. Look at that. Okay, the standard error of that. So that is so this is the standard error, for that. So when you plug in, you're just going to multiply by 1.96, and you know what I'm using 1.96 because at 95%, and at the end of the day, what I have here now is the confidence interval for the log odd estimate of the beta 1. If I now want to find the confidence interval for the odd ratio, what am I going to do? The confidence interval for the odd ratio, this is for the log odd, right? I'm just going to take the exponentiation of this and this. Okay, the exponentiation of each of that. The exponentiation of each of these will lead to this. Now, what am I trying to say? The other time, the 1.58 that we got was a point estimate, of the odd ratio. But we want to get it in interval. Okay, in the interval, it is between 1.3325 and 1.880. That's what we mean. So take a look at that. And let me tell you this. When you look at the odd ratio now, does this odd ratio include 1? Look at that. Does it include 1? Does it does 1 lies between 1.3325? Because in linear regression, when you are computing the confidence interval, we normally we can use confidence interval to investigate significance or not if it includes 0. But when you're talking about ratio, we don't talk about 0. We talk about 1. We talk about whether the interval include 1. When the interval include 1, there's no difference, right? When the odd ratio is 1, what is it meaning? When the odd ratio is 1, that's 50-50. Okay, it means there's no difference, right? So here, look at the interval now, 1.3325 and 1.880. There is no 1. in the interval. And because of that, what is your conclusion here? There's a strong association between parent and children smoking behavior. That is what we mean. Now, the next thing is you basically want to see the performance of the model by conducting what we call the analysis of deviance. All what you're just going to do is to do ANOVA into that very model and look at the p-value now. You know what are you trying to do here? You are comparing this model with nothing. It's like comparing the model with the parent smoke. Okay, you're comparing that with an intercept model. Okay, and what is the p-value now? As you can see here, you have a 0.000, which is less than any reasonable level of significance. What does that indicate? It means the model is fantastic. Now, the next thing I want to talk about today, using the same data, I want to use chi-square, this same data. You know, we just finished using logistic regression now, right? And the advantage using logistic regression is that the logistic regression can tell us how significant is a categorical predator. And not only that, logistic regression can also answer a question of association. I'm going to say this again. Logistic regression will tell us how significant is a categorical predator. And at the same time, logistic regression can also tell us whether there's an association. Take a look at this. How do I know? When you find the confidence interval for the odd ratio, look at that. When the odd ratio include 1, there is no association. There is no relationship. But if odd ratio does not include 1, if the confidence interval for the odd ratio does not include 1, then there is an association. The association is significant. So which means logistic regression can do the job of an association. Logistic regression can also do the job of telling us whether the categorical predator is significant or not. But you know what I want to do now? I want to use the method that we used on Wednesday on this same data. But I'm not going to go manual. On Wednesday, I did that manually, right? I want to show you now how you can do that in R. How you can do the whole thing that we did on Wednesday in R. So I want to use what we call chi-square test of association. Now I wanted to focus on the board, on the coding for the, using the chi-square. Like I said, on Wednesday, I walk you through this manually. It was at the end that we actually use R to compute p-value. You remember that, right? But right now, how you can actually do coding from day one. Let's take a look at this. You're going to write data table. Okay, data table, less than minus matrix 816188. Now look at the way 816188. I want to show you something now. 816188. You can see the one I wrote first is the one for the response yes. 816188. Then followed by this guy. I'm gonna write them together. Look at that now. I'm gonna show you now. Do you see 816,188? I'm writing the yes response first, followed by the no response. Take a look at that. And what am I doing here? I'm trying to say I want to generate a 2x2 table. 2x2. Look at that. N row equal to 2, N column equal to 2. Then what do I have? I have this guy now. Okay, can you see that? Now, if I just want to perform a chi-square test, you know what I'm just going to do? Chi-test into data table. Oh my God, we got our result now. Look at what we were doing on Wednesday. We were doing it manually. It was taking forever. If I give you assignment, okay, you can use this. This is the fastest way to conduct a chi-square of association when you are analyzing categorical variable. Take a look at that. Now, let's look at the result. Can you see the p-value, right? What is the p-value telling us? Of course, what are you testing? You have the non-hypothesis, right? You have the alternative. The null hypothesis is telling you there is no association between the two variables. No, the association between two variables is trying to tell you that whether the parents smoke or not, that does not determine whether their children will smoke. But the alternative is going to say whether parents smoke or not is a determinant to whether their children is going to smoke. So that was why we said under the null hypothesis, there is no association between the parents smoke and students smoke. That is the null hypothesis. But the alternative is there is an association between them. And how are we going to know? We look at the p-value now. The p-value is less than 0.05. Because of that, we're going to reject the null hypothesis. And we're going to say association exists, relationship exists between parents smoke and the children smoke. Look at that. That is the end of the story. Now, what I just demonstrated to you. Now, when you take a look at this, what is the disadvantage of this guy now? What is the disadvantage of a chi-square? The chi-square will only give us whether there's an association or not. The chi-square cannot tell us how significant is the predator. I'm going to say that again. Chi-square that I conducted right now cannot tell us whether the relationship, cannot tell us whether the categorical predator is significant or not. The chi-square cannot tell us. The only thing chi-square can tell us is whether there's an association or not. But you know what? Logistic regression can tell us the two. Logistic regression can tell us the two. Logistic regression can tell us whether there's an association or not. Logistic regression can also tell us how significant is a categorical predator. And that now comes to my conclusion here. Look at my conclusion. I said the logistic approach to tables allow you to assess the statistical significance. Look at the word statistical significance for the values of the categorical variable in a way. Look at that. That is one of the advantages of using logistic regression to analyze categorical variable, because it's actually going to enable us to to assess the statistical significance of the categorical predator. The one we use here today is the parent smoke. Okay, how significant is that? Logistic regression will tell us, but the chi-square cannot tell us that. Now, and I said the chi-square analysis only establishes a global statistical significance on the association between the variables. The chi-square will only tell us whether the relationship that exists is significant. That is what the chi-square is going to tell us. But let me tell you this. When you compare the chi-square of test of association with the logistic regression test of association, that of chi-square is highly recognized. I'm going to say this again. When you want to, I told you the other time that logistic regression also do the job of association, right? But let me tell you this. The association conducted in the framework of chi-square is more powerful compared to the one in the logistic regression. But the advantage with the logistic regression is it will assess whether the categorical predator is significant or not. And chi-square cannot do that. So I just, what I've done today is basically showing you, the method that we use in analyzing the categorical variable, situation where the response variable is categorical and the predator is categorical. And of course, the example today is for 2x2, two levels of response and the two levels of, predator. And as you can see, we actually fit a logistic regression model which enable us to assess the significance of the predator. The predator here is whether the parents smoke or not. Okay. And of course, I also use a chi-square test of association to first investigate whether a relationship exists or not. But let me tell you this, we need the two. If you are working on this area, you basically need the two. You need to conduct the two on your data set. For those of you, probably in your project, if your response variable is categorical and your predator is categorical, I will advise that you use both logistic regression and the chi-square. Because when you do chi-square test of association, it has more statistical power compared to the association you got with the logistic regression when you base your decision on the confidence interval of the odd ratio alone. So I just wanted to take note of that. Is there anyone who need clarification? Is there anyone who want to ask question before I go today? Is there anyone? Okay, before I go today, we are actually, uh, we're working towards preparing for the final. And like I said, this week, over the weekend, I'm actually going to release final practice questions. And let me also use this opportunity to tell everyone, initially, I proposed to have 10 assignments in the entire semester. But you know what? Eventually, I'm basically going to have just 9. You have a current one, right? Assignment 8, right? After assignment 8, you're going to have one more assignment, and that will be the end of the assignment for the entire semester. And let me also tell you this. Uh, I'm going to tell you now, uh, based on my principle, there are some things I may not put in the syllabus, but I look at the situation. We find ourselves in a world where at time when you propose, your proposal could be model, but model cannot give you exact reality. When reality comes, we're basically going to make an adjustment. Um, you're going to have just 9 assignments, and I'm only going to use 8. The lowest assignment, the assignment where you have the lowest score will be dropped. Will not count towards the final grade. And if you have done 8 assignments, but let me tell you, before the assignment can be dropped, before the lowest assignment can be dropped, you must have attempted 9 assignments. Currently, we have assignment 8, right? I said I'm going to give assignment 9. That will be the last assignment, but it is only 8 assignment that will count towards your final grade. Okay, the one that you have the lowest score will be dropped. When you just do 8 assignment, and you don't do the 9th one, then I'm not going to reckon with that. You need to do 9 assignment, but I'm going to drop the lowest one at the end of the day. And the final note assignment announcement today on the announcement, the university has released the SRT, where students actually evaluate their lecturers. You can actually, you're going to see the form on the course website. Okay, fill that, complete that. The university need a feedback from you, which is good for the system. Okay, so make sure, so it is a part of student obligation. You are required to fill the SRT, student rating of teaching. Okay, make sure you stay safe and have a lovely weekend and lovely Easter celebration. Okay, bye for now, everyone.